The strategy stays the same, right? Strategy, get a common denominator, multiply to get rid of fractions. What happens in example 2? They just up the difficulty in getting the common denominator, but it's not that hard. So in part A, can you see in the first one that you're missing the x minus 3 factor? And in the second one, you're missing the x plus 2 factor. Now, if on a quiz or a test you do this next, I'm going to be perfectly fine with it. Can you see that that's perfectly fine to do? If you like to show your work, you can put big brackets around the whole equation and say, actually what I'm doing is I'm multiplying by x plus 2 and x minus 3 on the whole thing, and that's why the bottoms are canceling out. If you understand that, though, and decide not to write the extra brackets and the extra multiplying and just say, in my head, I'm doing some pretty easy mental math. I'm multiplying both sides by this, which means those will cancel out. Then, what do I have? I'm going to have negative 3x plus 9 on this side when I distribute, and I'm going to have 2x squared plus 4x on this side. And what kind of equation is this? Quadratic. I was like, I'm glad you didn't make me rhyme again. We get a quadratic equation. How do we solve quadratic equations? We make one side equal to 0. 2x squared. If I add the 3x to both sides, I'll get plus 7x. I subtract the 9 to both sides. I get minus 9. I double check that I have factored or have moved everything over correctly. And now, either we have to use our skills at factoring or go to quadratic formula. Okay. Looking at this, if I was factoring, I'd right away know that this would have to be 2x and x. Then for 9, I'm going to try 3 and 3, or 9 and 1. 3 and 3 will give me 6 and 3, that never makes 7. But 9 and 1 could give me 9 and 2. Can you see that you'd want your 9 here to give you 9x and 1 there to give you 2x? Now the only way that then I could get a plus 7x is if I had a plus 9x and a minus 2x. Double check, does that give me my minus 9 at the end? Yes. Do I have my 2x squared? Yes. Does it give me the 7x? Yes. And so now in my head I think, if 2x plus 9 was equal to 0, I'd move the 9 over and divide by 2. This is equal to 0, I'd move the 1 over. X would equal 1. What were my non-permissible values? Because I have to do the check. Well, am I ever dividing? Yes. X can't equal negative 2, and x can't equal 3. This is therefore okay, and this is okay. I'm going to erase part A when I do part B. Is everybody good on part A? Same strategy, right? We got our common denominator, got rid of the fractions, and then had to analyze what kind of equation do we have now. The equation we had was quadratic, so then we used our skills to solve that. All right, part B. Notice that this one is missing an x minus 1. And then the second fraction is missing an x minus 5. And I had mentioned earlier, what are things that could make a question a little bit more difficult? Sometimes you can simplify in a fraction early. If you can simplify in a fraction early, you want to simplify, because dealing with fractions in simplest form are easier. I think I showed this to my grade 10 class, but maybe not to you. Right? If I got you to solve the following something nice and complicated, right? What is this equal to? 1. What did I try to do? I tried to make a half complicated here and a half complicated there. Simplifying this to 1/2 plus 1/2 makes your life a lot easier. Okay? As opposed to, and this is the danger in this unit, sometimes you will be tempted to do this. Ooh, I want to get a common denominator. I'm going to multiply this by 152 and this by 152, this by 772 and this by 772. Oh my goodness. Will you need a calculator? Absolutely. Will the numbers get huge? Absolutely. Could that cause you problems? Absolutely. Will that happen in this unit? Absolutely. So we have to be careful if we can simplify things, right? Getting this to 1/2 plus 1/2 makes our life a lot easier. So one thing you didn't notice me doing in this question is, first of all, I checked. Now these fractions are no common denominators, nothing common in this fraction, nothing to simplify. Nothing to simplify there. So it may appear that I just went on to getting a common denominator, but in reality, I am checking to see if things can simplify first, because it could make my life easier. And we will get questions that will do that. So, just as a check thing as you're going, we have solved x squared equations. So if you simplify and you get an x squared equation, I will tell you, yes, we've solved those before. Keep going. If you get an x cubed equation, x4 equation, x5 equation, we have not solved those yet. Chances are you could have simplified and you made your equation way too difficult. That's telling you to look back and see if there was something that would make it easy. Okay. If we do this, we're going to get on this side, I'll multiply it on x squared plus x minus 2, and on this side I'm going to get x squared minus 5x. Multiply both sides out. Is it quadratic? Yes. We've got x squareds on both sides. So let's combine our like terms. I'm going to move everything over, because I see quadratic, so I think I want to make everything equal to 0. So I move everything over to this side, which gives me 6x minus 2. And then I'm like, oh, my x squared went away. So now what kind of equation is it? It's just a regular linear equation. It's just an x. How do you solve those? You just get x by itself. So I would add 2 to both sides, then divide by 6. That simplifies to 1/3. We have to do our check with our non-permissible values. Well, are we dividing? Yes, x can't equal 5. X can't equal 1. 1/3 is fine. Perfect. Is everybody good on part B? Again, same strategy. Get that common denominator, get rid of your fractions, then analyze. Looked like we had to solve a quadratic equation all ready for factoring of the quadratic formula, but when we combine like terms, it even got easier. And part C. Part C, we have 7x minus 15 over. This can be factored. So we x as a difference of squares, x plus 3, x minus 3. So I factor first. Then I look, can anything be simplified? No, no factors are identical. Like this 7x minus 15 is one factor. Next thing I look at is getting my common denominator. That one's missing the x plus 3, x plus 3. So nice. We can multiply both sides by that, get rid of it, and now what am I left with on this side? 7x minus 15. On this side, if I multiply this out, x squared plus x minus 6. So we will get very good at foiling in our head. Okay, multiplying that out. That used to take like 3 minutes in grade 9. Drawing all the arrows. Remember drawing all the arrows and then writing it out and then combining your like terms? Yeah. Yeah. It's quadratic, so we set one side equal to 0. Do you want to wait until just we're done? Are you able? Because it won't take too long, but I want to show you something in this question. So if I make it equal to 0, that means I'm going to subtract the 7x on both sides. I'm going to add the 15 on both sides. That'll give me plus 9. And this factors nicely to x minus 3, x minus 3. So we get x equal to 3 twice, but there's only one answer, is x equal to 3. The last thing we need to do is our check. What were our non-permissible values? We're dividing by plus 3 and minus 3, so x can't equal.
Hi there.
Hello.
Is Julia in class?
No, but thank you for reminding me to do my attendance.
Wonderful, thank you.
Okay, well, we'll finish this question, then I'll do attendance. Because we're almost done. And what do we notice? Oh my goodness. Those were non-permissible values. The only solution we got ends up being a non-permissible value, so we need to write that this question has no solution. Circle questions 6 and 7.